Hello, my name is Maurizio Pogliani. I'm a field application engineer. We are talking about power design summary related to the LTpowerCAD. In power design summary, you can combine the project's main specification into a single easy-to-consult report. It includes steady-state information such as duty cycle and the ripple voltage, so you can have information about the efficiency and the power loss data at full load. Loop characteristics along with the load transient results. The bill of material, and you can also estimate the PCB area taken by the circuit. From the power stage design page, you can go to the power design summary, and it is the last tab on your window. You can go there, and here you can find all the information that you need as a result of your design, starting from the design specification and all the power components and the footprint of your power components. Now we can go in detail talking about design specification. So here are the design specifications. In the table, you have the summary of the number of the arrays that you are using. You have the minimum, nominal, and the maximum input voltage, the switching frequency of your device, the output voltage, the ripple in terms of volt peak to peak on your output voltages, and the ripple in terms of percentage respect to your nominal DC voltage regulated. You have the output maximum current, you have the ripple current on your power inductor, you have the ripple current in terms of percentage, and the peak current in your inductor. In addition, you have the duty cycle, rail by rail, and the minimum on time and minimum off time of your device. So we talked about the steady state information related to the design specification, and now we're going to talk about the efficiency and loop. On the two rails, we have the output voltage, we have the maximum output current, and we have the efficiency at this maximum output current and the related power losses. You also have information on the loop bandwidth and loop phase margin, and then you have the value of the step load applied to your system. So you have the low step, the high step in terms of current, and then you have the slew rate of your step and the output variation in terms of millivolt AC and in terms of percentage respect to your nominal output voltage DC. Here you can see the summary of the power components that we have in our design. So this is the bill of material, and you can export it, and we have the list of all the power components that we are using. The blue cells are editable by the user, so the user is able to change the part number of the device that decided to use during the design. And then you can select also the package of your device. For example, you can select the 0805 for a cap, and it appears the size of the device, and this size will be summed in the power component footprint. Here you have the power component footprint. So you have the number of the component that you are using, the maximum height. You can decide the component clearance. So in this case you have 1.5 millimeter, but it could be also 1, for example. And then relating to this clearance, you have the power component area, including the IC and excluding the IC that you are using. placement layout recommendation can be accessed by clicking on the View Layout Example icon. So it's strongly recommended to use the demo boards as point of reference for proper placement and layout. So you can refer to our application note AN 136 and 139. LTSpice and LTpowerCAD are complementary to one another. LTpowerCAD simplify the design phase, while LTSpice allow a first-level verification of whether or not the circuit design meets the targeted performances. Currently, all component values and operating parameters are passed as parameters in LTSpice using the .param spice directive. So here is the link to LTSpice, and here you have the schematic in LTSpice. Here you can see all the parameters exported by LTpowerCAD, and here you have the simulation model, so you can start to simulating the electric circuit. So remember that once the design is in a good shape, you can access to the Power Stage Design toolbar, where you have the view of layout example, the export to LTSpice, the download and view of demo board files, the download of datasheet of the part that you are using, and in addition you can go to the LTC toolbox. Opening the LTC toolbox, you have the access to LT Power Planner, to the resistor divider tool, and to the copper RL calculation design tool. To help you in a good design of the DC-DC converter, so we can suggest you a list of relevant application notes. So the AN 19 that is related to design and loop compensation of various SMPS topologies, the AN 76 that is main focused on the loop compensation, and the AN 149 that is modeling a loop and loop compensation design of switching mode power supply. That's all from my side. Hope you are enjoying LTpowerCAD, and buon lavoro a tutti!